Statistics and Excel bell curve people weight example part number 1. Get ready, taking a deep breath, holding it in for 10 seconds, looking forward to a smooth, soothing Excel. First, a word from our sponsor. Yeah, actually, we're sponsoring ourselves on this one because apparently the merchandisers, they don't want to be seen with us. But that's okay, whatever. Because our merchandise is better than their stupid stuff anyways. Like our crunching numbers is my cardio product line. Now, I'm not saying that subscribing to this channel, crunching numbers with us, will make you thin, fit, and healthy or anything. However, it does seem like it worked for her. Just saying. So, subscribe, hit the bell thing, and buy some merchandise so you can make the world a better place by sharing your accounting instruction exercise routine. If you would like a commercial-free experience, consider subscribing to our website at accountinginstruction.com or accountinginstruction.thinkific.com. Here we are in Excel. If you don't have access to this workbook, that's okay because we'll basically build this from a blank worksheet. But if you do have access, 3 tabs down below: example, practice, blank. Example, in essence, answer key. Practice tab having pre-formatted cells so you could get to the heart of the practice problem. The blank tab, blank worksheet with just our practice data so we can practice formatting the cells within Excel as we work through the practice problem. If you don't have access to practice data, you could use resources such as Kaggle.com. You can also try to create your own data to practice with by going to the data tab up top, the analysis group, and the data analysis tool that we saw in a prior presentation. If you don't have this analysis group, then you can go into the options and possibly add it, as we saw in a prior presentation as well. Back to the home tab, down to the example tab to get an idea of what we will be doing. Our data is going to be related to weights of people. We also have heights if you want to practice with that as well, but we're focused on the weights this time, measured in pounds. Now, this will be similar to what we've seen in the past. There's a couple major differences, however. One is going to be that we have a whole lot more data of weights. And weights, as you would imagine, you would think that because it's something that's related to nature, people's weights, that it would follow a bell-shaped type of distribution. The more data that we have, the more likely that the actual example, if it conforms to a bell-shaped distribution, will simulate a bell-shaped distribution. So that's one thing. We have a lot more data in this example than prior examples. We're also going to be building our graph over here, and we're going to use a similar technique, but slightly different in the technique to get this between column that we will then use to build our graph, trying to come up with some strategies that you might be able to build your graphs fairly quickly so that you can use them when you're working these practice problems. And we'll do a little bit more with the z-score calculations and formulas as well. All right, let's go to the blank tab and get started. I'm going to remove the Kaggle thing. I'm going to select the entire worksheet this time and format the data before we get started. Selecting the triangle, right-clicking on the worksheet, formatting the cells. I'm going to go to currency because I'm an accountant. That's where I like to go. I'm going to say negative numbers are bracketed and red. And I'll keep the decimals for now. Let's go 2 decimals, but no dollar signs. These are not dollars we're talking about. Now, if I say okay, obviously it trimmed up our data over here to just show the 2 decimals, even though it had more than 2 decimals, right? Now, what I'm going to do is we could just hide the heights. I want to keep the heights there just because you might want to use those in practice in a similar method. You can do basically the same sample problem we're doing here, but with the heights data if you want. But I don't need it right now. So I'm going to go ahead and select columns. Well, let's first put a table around it and then I'll hide them possibly. So let's go up top, make this bold, home tab, fonts group, bold it, and then I'll put my cursor somewhere in this group of numbers and go to the insert tab, tables group. I'm going to add a table to it. The dancing ants are doing their table creation dance. Looks kind of like a rain dance. It's hard to tell, but it's different because obviously how would Excel know what to do if they did the same dance for everything, you know? So in any case, home tab, alignment, wrapping the text, and I'm gonna double click in here and just put some space so I can wrap the text where the space is. All right. And then I could just hide columns A and B because I'm not using those. So I'm going to put my cursor on A, go over to B, right click and hide them. Just hide it. Now, note that if I was going to sort this data somehow, possibly I had some blank cells in here where we didn't get the weights, or we have some very high or low weights that don't look correct or something like that, then I might want to filter out those outliers that might not be correct depending on what I'm doing. If I was to do that, I would want my data on a separate tab, because once I start filtering things, it'll collapse the rows. So, but here I'm not going to do that. So I'm just going to keep my data on the same tab here, and we'll do our normal calculation. So I'm going to make a skinny D, and then we're going to say, sounds like a rapper's name or something, Skinny D. Skinny D's up, throwing down the bass beat and doing some licks over it or something. Anyway, here's the mean equals the average tab. We're going to select our data. Now there's a lot of data. I'm going to select the data, boom, and it's going to just pick up that entire table. If I go Control Shift down on this data, we're at 25,000 data points. So we have a lot more data. Control backspace, and then I'm going to say, all right, let's do the standard D. I'm just going to call it SD for the standard D. I'm going to say this equals ST. This is the population, so I'm going to pick up the population, STDEV for the pop, and the population, not your dad, the population, the pop. That's what I call it, the pop. And then we're going to say, okay, and then the median, the one in the middle, hit the one in the middle. We're going to say the median tab, picking that up, boom. And then the mode might not always be as applicable if you didn't have a whole lot of data, because that shows if multiple items are being hit. And because we're using fractions of pounds, then it would be less likely. But since we have a whole lot of data, the mode will probably be applicable here too. Let's say the mode, single mode, just one, please. I don't need like a whole bunch of modes. Boom. And okay, so now I can see that the mean is pretty close to the median, which is an indication that this group of data follows somewhat closely to the bell curve, and the mode is also there. Remember, the mode's kind of tricky, because if you didn't have a whole lot of data, the mode, they might not even have a mode, because you have these fractions of the measuring, in this case of pounds, which means that you might not have a lot of duplicates. Whereas if you rounded them to a pound, it's more likely that the mode is going to be more applicable. But again, we have so much data right now that the mode will work. So now I'm going to say, all right, I'm going to graph this thing out. And so I'm going to make a bell curve, because it looks like a bell curve would work. Before I do that, let's actually let's look at this data in terms of a histogram. If I select the entire thing, I'll just select the data. If I just select the data, then I'm going to go into the insert and then charts and just make a histogram and say, what does this thing look like from a histogram standpoint, where we have the groups on the bottom, and then how many, and this is the buckets on the bottom, and how many of these numbers, which there's a whole lot of them, fall into each bucket. Now the point here is that this time we came up with something that looks a lot more like a bell curve than some of our prior examples, due to the fact that we have a whole lot of data here. We're using a whole lot of information. So if you're looking at something that would conform to a bell curve, you would think that if you had the more data that you had, the more smooth looking the shape would look, and the more you can be kind of certain that it looks like it follows a bell curve type of distribution. So we're going to go, okay, it looks like a bell curve kind of does the thing. I'm going to move this off to the side, and let's start to build an actual bell curve. So I'm going to say, let's say that this is going to be X. This is our X. This is going to be P of X, let's say. I'm going to make this black and white. So we're going to go Home tab, Font group, making this black and this white and then I'll center it, and then let's make a skinny X, skinny up the X. It's on the lighter side of our bell curve. It weighs less because it's skinny. It's a skinny X. But it could be skinny with big bones, you know, it just has, but in any case. So now we're gonna say, okay, well, what am I gonna start? Because I'm measuring in pounds. I could start from like 1 pound and go up to like, I don't know, 500 pounds or something. But I don't probably need to go that far because it's not likely that someone weighs 1 pound. So what's the range that I need on my X's that are gonna be on the X parameter? So I could say, well, everything, let's do that 4 standard deviations again. That should pick up almost everything in 4 standard deviations. So let's go that we're gonna say the numbers of standard deviations, which I'm just gonna say SDs in our chart, the number of X's that we want are going to be equal to, well, let's just say 4 of them. And so that means that the lower X and then the upper X we can calculate. So the lower X is going to be the mean, the middle point, minus the standard deviation, 1166, times 4 of them to go 4 standard deviations. And we're going to say, okay, boom. So we've got 80. So people don't weigh less than 80 oftentimes, right? And then we're going to say pounds. We're talking pounds. I know if you're not in the United States, you're like, what are you talking about? Or why a pound? What in the world? But whatever, that's how we do it, man. So now we're going to say the upper one is going to be 127 plus a standard deviation times 4 and enter. So now 173 pounds is going to be our upper end. Okay, and so now let's just build this. I'm going to say this is going to be an X of, let's go from starting point is just going to be 1 less than this one, or 80, you know, at the lower end. I'm going to get rid of the decimals because I'm not going to do the decimals here. I'm just going to take it to the whole pounds, and I'm going to drag it. Well, let's do 81 so we can see the pattern. Get rid of the decimals. Select those two. I'm going to drag it down to 174. 174, and that should be good. So I'm going to drag it down until I get the pattern down to 174. That doesn't even fit me, man, because I'm yoked up. What about someone like me that's like huge, like Arnold Schwarzenegger, but not now because he's old, but like when he was, I'm not, you know, when he was not old. No, anyways. So now we're going to say P of X, we're going to say this equals then norm.dist. So we've seen this in prior presentations. So we're just going to take the norm.dist. I won't do the spill function this time. I'll just do the normal process. So I'm going to take the X, comma, the mean. The mean is outside the data we're working in. So I'm going to F4 it, making it absolute so it will copy down and not move that cell down, comma, the standard deviation is that one. Again, it's outside the data I'm working with. I don't want it to move down, so I'm going to select F4, $ before the F and the 3, making it absolute, comma, cumulative, not cumulative, false or 0, and then enter. I'm going to percentify it, home tab, number group, percentify. You better percentify if you want to recognize. I still don't recognize, it's still 0. But if I double click on the fill handle, copies it down, and there we have it. Now if I was to total this up, total, and say alt equals to sum, trusty sum formula, we get 1 or 100 because basically all the data is in there. All right, so that looks good. And so now I'm going to say okay, so now let's ask, well, let's see how closely that fits to our actual data now. Now remember, our actual data is actual samples, not given to us in percents. So I want to either adjust my actual data to percents or adjust this curve to actual data, right? So first I've got to take all of my information here and group it together. And that's going to be our frequency. So this is going to be the actual frequency, and then I'll wrap that, home tab, alignment, wrap it, center it, black, white, So this is going to be the one where we're going to say the frequency is going to tell us everything. For example, this one that is above 80 up to and including 81 is going to go into that bucket when we count our actual data. All right, so we're going to use our frequency, which is a spill array function. Frequency tab. I'm just going to select all of our data with the little arrow, selecting all of the data, comma, and then I'm going to select all of my x's by putting my cursor on the top x, control shift and down arrow. Don't want to pick the total, so I'm just going to say shift up and then control backspace to get up to the top without the dancing frequency ants stopping their frequency dance. And then I'm going to say enter, and boom, spills it on down. So these are the number of occurrences of these datas that are in between 100 in this case, or above 100 up to and including 101. I don't want it spilled down a little one more than I wanted it to go. So I'm going to double click here. I'm going to get rid of that last one so it spills out right to there. Now, if I sum this up, how do I know it picked up all my numbers? Well, if I say alt equals down here, summing it up, comes out to 25,000, and I could say, does that equal my count of data? Right, I can check my actual count and say, how many data points do I have over here? Imagining these are our bunch of data that we actually counted, right? So we're going to say this is going to be count. I'm just going to say count all of my data. How many are there? There's 25,000. We picked up all 25,000 are represented in one of these buckets. So that looks good. Check, confirmed. So now I can either convert my percentages to counts by multiplying all the percentages by 25,000. Then I can compare my actual to the smooth curve, or I can convert, which is probably the better thing to do, the actual frequency to the percent by taking the percent of the total. And I'm going to say, let's go home tab, numbers, black, white, wrap it, center it, and I'm going to do this by saying this equals this number 2 divided by control shift down. I just want to pick up that 25,000. So it's just that number 2 divided by the 25,000. I want it to be absolute. So F4 in the keyboard, $sign before the J and the 9, enter. I'm going to percentify this whole column, or I could just do this one cell and then copy it down maybe. Home tab, number, percentify, so we can recognize, and then add some decimals, and then double click on the fill handle, and boom, it copies it on down. So now we're comparing these percentages, and I could say, okay, what's the difference between our percentages? Difference between what we got to what we would have predicted if we used these numbers and multiplied times our 25,000 count or something, right? Or got our percentages. So let's go to the home tab, font, black, white, alignment, center, wrap, and then difference equals the P of X minus the percent of total. I'm going to percentify it, home tab, number, percentify, add some decimals, double click it down on the fill handle. And so you can see the differences are pretty low for the most part. So once again, indication that this could conform to a bell curve, and a bell curve could give us good information about this data. Okay, so now we want to say, okay, let me graph this thing, this actual bell curve. I could graph it first to just see what it looks like in terms of our percentages. So I'm going to put my cursor here, control shift down, shift up so I don't pick up the total, scroll back up to the top, insert. I'm going to go to the charts. First, I'm going to just hit the bar chart, and let's just take a look at a standard bar chart. There it is. There's our bar chart. And so now I can say, okay, maybe I can look at this bar chart and compare it to my actual percent data. So remember, we did this one over here with the numbers, but now I'm going to do it comparing it with our percents of the actual data and put them on top of each other. So before I do though, I'm getting ahead of myself. Hold on, hold your horse. Hold your horse. Your horse is tired, it needs a hug. So I'm going to change this bottom bit because it shouldn't start at 1, it should start at 80. Selecting the data, chart design, data, and I'm going to say selecting the data, edit group on the right, and then we'll select this item. I'm going to put my cursor on the 80, shift down, control or just shift up so that I don't pick that up. And then I'm going to say okay and okay. So make sure to check it on this side because sometimes it gets a little picky over here and it doesn't pick it up, but it looks like it did it. So there it goes. So there's our smooth bell curve. Now let's add this on top of it to see our actual data in percent form on top of the bell curve stuff. So I could then go to the data and I could say, let's add another. It's going to be the percent of the total as the name. Delete this stuff. Make sure it's a little tricky here. It gets a little sketchy. It's not hard, but sometimes Excel doesn't do what you tell it to do. And you got to be like, okay, Excel, I'm not mad. I'm not mad or anything, but you're not doing it. You're not doing what I said to do. And it's just frustrating. I'm just disappointed. It just disappoints me when you do that, Excel. And then if you talk to it nicely like that, then it usually starts to work. So that you can see that this lines up pretty close, our actual data, and that you can also do that with a line graph. I probably should show a line graph just to show the difference, but that's the idea. So now I can say, all right, now I can make an area chart of it if I wanted to, because we're usually thinking about terms of areas, not the bar chart. So I can take my actual bell curve and say my bell curve is good to go now, and let's make an area chart with it. So I'm going to go up top and say I want to insert this time an area thing, an area chart, not just like a thing. And then we'll say okay. And so now we have the area. And I once again need to change the bottom bit down here. So I'm going to go to my data, and then this one on the right, I'm going to then say I want you to be the X stuff here. And then the dancing ants do their X axis dance. See how it didn't do it? See that? Excel, why? I'm not mad. I'm just saying. Like, I picked up the numbers correctly and you didn't bring the X's in there. I see what you did. Pick those. You see the dancing ants doing their X axis dance. Get it right. See, then it picked it up. So you just have to get a little, you know, you got to watch them. You got to watch Excel. They mess with you sometimes. So there's that. So now what we would like to do, and we'll do this next time, we'll continue on to adjust this graph so that we can then ask questions like, what if X is, you know, greater than so much? And we'll do the between thing looking a little bit differently, and we'll also add the z-scores as well, and add those to our graph in the following presentation.